So today we'll be doing class 7 physics, and the topic for today is heat and temperature, chapter 5. So we've completed chapter light also, and I told you to do the work, the question and answers from the text. I hope you've done it. And today we'll be starting a new chapter, that is heat and temperature, that is your chapter 5. Now, before we start, let's quickly revise. There are different forms of energy. Light is one form of energy. Heat is another form of energy. And what is the definition of heat? So heat is a form of energy which helps us, or which gives us a sensation of hotness or coldness. Okay. And before we move or we discuss more of heat, we'll first discuss about temperature. So now see here, the definition of heat. What is heat? It is a form of energy that gives us the sensation of hotness or coldness. Then, what is temperature? Okay, temperature is the measure. It is not the form of energy. It is a measure which gives us the sensation of hotness or coldness. For example, there is a cup of tea kept on a saucer on your table, and then you are asked to take it. When you take that tea, you drink it accordingly. So if it's hot, you sip it very slowly, or you blow the air above it, or if it's cold, you just gulp it, isn't it? So, why and what tells you that this is hot or cold? It is the temperature. If the temperature of the tea, the drink, is more, it will be hot. If the temperature is low, then it will be cold. Okay, so temperature is the measure of hotness or coldness. That means how hot or how cold an object is, we measure. What is that measurement called? Temperature. Now, there is an instrument used for measuring temperature, and you've seen it in your day-to-day life, isn't it? You see it in the lab, you see it at home also. You see it most of the time. And that instrument which measures the temperature is called thermometer. Okay, and the word thermometer means, thermo means heat and meter means measuring device. That is heat measuring device. Okay, so thermometer means heat measuring device. So thermometer measures the temperature. That means how hot an object is or how cold an object is. Okay, so you can see over here, this is your thermometer. Now see here, what exactly a thermometer would be. A thermometer is made up of glass. Okay, and then inside it you will have a thermometric liquid. That thermometric liquid can be mercury or alcohol. Okay, depending upon the place. And then you have the reasons over here. You can see the scales here from 0 to 100, and this is your degree Celsius scale. So in either you put the thermometric liquid as alcohol or mercury, then this is how it measures. If the temperature is high, this level will go rise, and if the temperature is low, this level will come down. Then there's a narrow tube. This narrow tube where the mercury is filled in, isn't it? Or the alcohol is filled in. It either goes up or comes down. Now it is given here. It is made by filling the glass bulb and the capillary tube with mercury or alcohol. After heating to drive out all the air, the capillary tube is then sealed. That means after driving all the air from here, it is completely sealed. That means no air can get in. Okay. As the liquid cools and contracts, the space above it in the capillary becomes practically a vacuum. Means this space, okay, the space here, empty space, that will be completely empty. That means there will be no air. All the air has been removed. Okay, so that the reading would be correct. Got it? Now these are the different forms of thermometer. This is your clinical thermometer. I'm sure this is what we all have in our home, isn't it? To measure our body temperature. So every time we have a fever, we use this to measure our body temperature. And this is your non-contact digital thermometer. In the current scenario where there's the corona, there's a pandemic going around. This is non-contact thermometer. Okay, so this is used to measure the temperature of a human body. That means they can sense it from without touching it. Okay, just have to be near, but they can sense it without touching it. So the body temperature can be recorded without touching the body itself. Now, as I told you already, the substances which are inside the thermometer are called thermometric liquid. Okay, and there are two types of thermometric liquid. One is mercury, the other is alcohol. Okay. Now see here, this is your mercury thermometer and this is your alcohol thermometer. Now you might be wondering, why is this red in color? Isn't it alcohol red in color? It is because the alcohol, you know, as it is, it's colorless. So in order to be visible, okay, in order to see it prominently, you just add the color. So the alcohol, what is added? Color is added. Okay, it can be red, it can be black, it can be any color which is distinguished, which can be seen clearly. Okay, this is your alcohol thermometer and this is your mercury thermometer. You know what mercury is. And mercury is quite visible, it's shiny, isn't it? Now, the difference between mercury thermometer and alcohol thermometer. The alcohol thermometer is a thermometer in which the thermometric substance is alcohol, whereas mercury thermometer is a thermometer in which mercury is the thermometric liquid. Okay, and the liquid inside the thermometer would be purely alcohol or kerosene, whereas inside the mercury thermometer it would be mercury. And alcohol is less toxic than mercury. Okay, alcohol would be less toxic than mercury thermometer, which means alcohol is less toxic than mercury. And alcohol thermometers are used only in regions where the temperature is very less, okay, where the temperature might fall below -50°C and all. Why? Okay, if the temperature is really low, the places where the temperature is very low, there we use alcohol thermometer instead of mercury thermometer, because the freezing point of alcohol is very low. Okay, the freezing point of alcohol is very low compared to mercury, whereas mercury freezes at a higher temperature compared to alcohol. That's why alcohol is used in very cold places as a thermometric substance, whereas in places where the temperature is high, instead of alcohol, what is used? Mercury. Okay, because the boiling point of mercury is very high. That's why mercury is used for places for very high temperature, whereas alcohol is only used in places where the temperature is very low. Now see the measurement. What is the temperature that the alcohol can measure? It's up from -115°C. That means if the temperature freezes, okay, if the temperature decreases to -78, -80, -90, which is extremely, not just extremely, very cold, okay, there we can use alcohol thermometer. And the measurement of mercury is -37°C to 356°C. That means in a place where the temperature falls to -50°C, we cannot use mercury, because mercury's freezing point is -37°C, which means mercury at -50°C will freeze. Okay, before it reaches -50°C, and thus the temperature will not be able to be recorded. That's why in cold places alcohol is used as a thermometric substance, and in places where the temperature is high, mercury is used. Okay, now the other difference is it's less durable because alcohol evaporates quickly, and that is one reason why mercury is often used as a thermometric substance. Okay, you know alcohol is available anywhere, everywhere, but we don't use it as a thermometric substance, isn't it? Generally we see a thermometer with mercury as the thermometric substance. It is because alcohol evaporates quickly. It's a volatile substance. Okay, you know what volatile means, which vaporizes quickly. Okay, that's why mercury is preferred than alcohol. And the other disadvantage of alcohol is alcohol weights the wall of the, that means you can see that when the alcohol droops down, that means if the level of the alcohol comes down, there will be some alcohol attached to the walls of the thermometer. Okay, whereas mercury, they do not stick to the wall. That is one advantage of mercury. Alcohol is dyed since it is colorless. I told you we add colors like red. We saw that red color alcohol, isn't it? Thermometer. So why do we see red color? Because it is dyed. Color is added to it. Whereas mercury is itself shiny and it's clearly visible. That's why we don't need to add any color to it. We don't need to dye the mercury. Okay. So these are the differences between mercury thermometer and alcohol thermometer. Why alcohol is used, where alcohol is used as a thermometric substance, where mercury is used. What are the advantages of mercury over alcohol thermometer? So you can see it from here. Now, there are three scales in which we can measure the temperature. Okay, the first one is Celsius scale, also known as centigrade scale. Okay, so this is your Celsius scale, and you can see the thermometric substance here. Okay, this is your Celsius scale. This is your Fahrenheit scale. Okay, this is Fahrenheit scale. The second type of scale where the temperature can be measured is your Fahrenheit scale, and it is written with degree Fahrenheit. Okay. The lowest point for Fahrenheit is 32 degree Fahrenheit. That means the water freezes at 32 degree Fahrenheit. This is the lowest temperature. The highest temperature for Fahrenheit scale is 212 degree Fahrenheit. That means water boils at 212 degree Fahrenheit. Now, see here, Celsius, the lowest is 0 degree Celsius. The highest is 100 degree Celsius. Okay, for degree Celsius, lowest is 0. That means water freezes at 0 degree Celsius. And water boils at 100 degree Celsius. That means how many divisions will Celsius scale have? 0 to 100. That means 0 is the minimum and 100 is the maximum. For Fahrenheit, 32 degrees Fahrenheit is the minimum and 212 degrees is the maximum. So there are 180 divisions. That means you can see the lines here. How many lines will be there between 32 and 212? 180 lines. Okay. The third type of scale with which we measure temperature is your Kelvin scale. Okay. Now, for Kelvin scale, the lowest temperature, that is where the water freezes, is 273 Kelvin. Whereas the highest temperature, that is the maximum temperature where the water boils, is 373 Kelvin. And how many divisions are there? How many lines are there between 273 and 373? 100. Okay, so there are 100 lines between 273 Kelvin and 373 Kelvin. Now there is a temperature, okay, which is called absolute zero. What do you mean by absolute zero? Absolute zero means the lowest temperature. Okay, it is considered to be the lowest temperature existing, the lowest ever temperature existing, below which, what we consider that, in which the motion of the particles, they cease, that means they do not move at all. Okay, that is the lowest temperature where the particles are considered, they are no longer in motion. That means they cease to move, they stop moving. Okay, that is your absolute value. That means at that temperature, all the particles of an object, they stop moving. Okay, that is called absolute, and that temperature is called absolute zero. It is the lowest possible temperature, and something at this temperature has the lowest possible internal energy. That means the particles are considered to be they consider to be frozen. They do not move at all. Okay, they cease to move. But then that is theoretically. Practically, it has not been proved. So this is 0 Kelvin, which is for Celsius the lowest. For Celsius, we can see that for Celsius the lowest, that is the absolute temperature, is minus 273 degrees Celsius. For Kelvin, the absolute zero is 0 Kelvin. And for Fahrenheit, the absolute scale is minus 400 degrees Fahrenheit. So see here, you can compare them, Fahrenheit, Celsius and Kelvin. Okay, so when we compare them, the lowest for Fahrenheit is 32 degrees Fahrenheit. For Celsius, the lowest is 0 degrees Celsius. For Kelvin, the lowest is 273 degrees Kelvin. The highest for Fahrenheit is 212 degrees Fahrenheit. The highest for Celsius is 100 degrees. And the highest for Kelvin is 373. Okay. The division between, in a Fahrenheit, that means the number of lines between 32 and 200 is 180. Between 0 to 100 is 100. And between 273 to 373 is 100. Okay. So these are the differences and the comparison between Fahrenheit, Celsius and Kelvin. Now see here. And we have the human body temperature also. What is the human body temperature? That is the normal temperature. In Fahrenheit scale, it's 98 degrees Fahrenheit. In Celsius scale, it is 37 degrees Celsius or 38 degrees Celsius also. And for Kelvin, it's 310. Okay, 310 Kelvin is your normal body temperature. 38 or 37 degrees Celsius is for Celsius scale, and 98 degrees Fahrenheit is for in Fahrenheit scale. So we discussed this. Now, with this, what do we come? So these are the three different types of scales that we discussed. One is Fahrenheit, the other is Celsius, and the third one is Kelvin. What is the lowest point for Fahrenheit? 32 degrees Fahrenheit. Highest 212. And how many divisions are there? 180. And what is the normal body temperature for in Fahrenheit scale? 98 degrees Fahrenheit. Now when we come to Celsius, what is the minimum temperature? 0 degree. Highest 100 degree. Number of divisions 100. Okay, in Celsius, degree Celsius. And what is the normal body temperature? 37 or 28 degrees Celsius. In Kelvin, the lowest is 273, the highest is 373, the number of division is 100, okay, and the normal body temperature is 310. Now, there are relation between Fahrenheit and Celsius, Fahrenheit and Kelvin, Kelvin and Fahrenheit. That means we can convert Fahrenheit to Celsius, Celsius to Fahrenheit, and we can convert Celsius to Kelvin. So we'll be doing that. Okay, there's some of the numericals. So this is the relation between Fahrenheit and Celsius. If you have to calculate Fahrenheit, if the value is given in Celsius, this is the relation. F equals to 9 by 5, C stands for Celsius plus 32. Now see here, one numerator related to it. See, the temperature is given in Celsius. And what is the temperature given? It is 89.2 degrees Celsius. Okay, the temperature given is minus 89.2 degrees Celsius. Now we have to convert this temperature into Fahrenheit. So using this relation, F equals to 9 by 5, C plus 32. Okay, so 9 by 5 is down there. Instead of C, what will we write? We write down the value of, what is the value of temperature given here? Minus 89.2. So where there is C, we write down it minus 89.2 plus 32. So when we do the cancellation, you do the cancellation here. Whatever answer you get, add it with 32. Okay, so when you do the cancellation with 9, first multiply them and then do the cancellation with 5. And then whatever answer you get, add it with 32. So what do you get the overall answer? Minus 128.6 degrees Fahrenheit. Now, Celsius has been converted to Fahrenheit. Okay, so minus 89.2 degrees Celsius in terms of Fahrenheit is minus 128.6 degree Fahrenheit. Now, if we have to convert Celsius to Fahrenheit, in the first one, if we have to convert Fahrenheit to Celsius, in the first one, what did we do? We converted Celsius to Fahrenheit. Now we'll do just the opposite. We'll convert Fahrenheit into Celsius, and this is the relation. Okay, C is equals to F minus 32. This is into 5 by 9. F minus 32 into 5 by 9. And when you are solving this, please make sure that you follow the BODMAS rule. Now see here, F is given. How much is your F given? 5 degree Fahrenheit. That means the temperature given here is in 5 degree Fahrenheit. So C by 5 equals to, using this relation, what do we have? C, where there is F, okay, F minus 32, so instead of F, what will you write? 5 minus 32. So when you solve this, okay, C by 5, 5 minus 32 is minus 27 divided by 9. And when you do the cancellation, 27 can be cancelled by 9. And how many times? 3 times. And there is a negative sign here, that's why we have a minus sign here. So this 5 goes that side. So C equals to minus 3 and 5 in the division form. When it goes to the other hand side, it will be in the multiplication form. So when you multiply, what do you get? Minus 15 degree Celsius. That means 5 degree Fahrenheit, when you convert 5 degree Fahrenheit to Celsius, what will be the value? Minus 15 degree Celsius. Okay, so this is how we convert Celsius to Fahrenheit and Fahrenheit to Celsius. Now this is the relation between Kelvin and Celsius. We have relation with Kelvin and Fahrenheit also, but then that is not there in your syllabus, so I just chosen this Kelvin to Celsius. It's very easy. If you are converting Celsius to Kelvin, what you have to do? You simply have to add 273. And if you are converting Kelvin to Celsius, you simply have to subtract minus 273. Remember, this is a very important note. When you are converting Celsius to Kelvin, add 273. And when you are converting Kelvin to Celsius, minus 273. Now see here, example. The temperature is given in Celsius, 30 degrees Celsius. You have to convert the Celsius to Kelvin. Okay, and when you are converting Celsius to Kelvin, you simply have to add how much? 273. So when you add 273,